Hello everyone. Hope you guys are enjoying this session. Like this is a session for AIML. It is gonna be a long session where you're gonna learn everything from scratch, from building how you can generate the data, how you're gonna build the model, how you're gonna evaluate it. Everything gonna be very scratch thing. And yeah, guys, hope you guys are enjoying, and we are also enjoying. So today we're gonna see data processing, data pre-processing. So please, as we are mentioning, please watch the previous sessions so you can have a better understanding of what we are doing now. Okay, so without wasting any time, we will just jump into today's session. So today we're gonna see the continuation of data pre-processing case. So numerical data normalization. So numerical data normalization means, guys, consider. Okay, I'm gonna tell an example and then I will explain this. So we are having two different columns, guys. So first column is like a, consider it is like a column which has the liter of milk. Okay, so it will be just counted in 1 liter, 2 liter, 3 liter, like that till 9 liters we are having. Okay, so next column we are having consider we are having the age of the person. Okay, like two-digit numbers, right? Like 20, 21, 22, like that. Okay, so I will say the model will treat these two columns in a different manner. That is, the first column has a single digit number, whereas the second column has a two-digit number. What happens means the model consider the two-digit numbers are more more important and give more importance to it. So what we need to do means we need to normalize everything. We need to make it some standard scales. Okay, so we are having two different methods. One is min max scalar, another one is is score standardization. So in min max scalar, we will be making everything to a range of 0 to 1, so that what happens means there will be no like one digit number, there will be no two-digit number, nothing. We're gonna have all the values to zeros to one. So the whenever the model is training or whenever model is learning, right, it will treat everything as the same. So that's the reason we are doing that. And one more thing, we are having a z score standardization. It transforms the mean value to 0 and the standard deviation to 1. So based on that, it will convert all the data to the mean value of 0 and then the standard deviation of 1, making the data less sensitive to the outliers. That is, it makes everything normalized and model can learn without memorizing. Okay, it will generalize and it will learn. So this is what all about this numerical data normalization. Yes, sir. Over to you.
Yes. So, guys, normalization. First, let us understand what is normalization. We need to normalize the data. It can be in different forms, okay? But we have to make it normalized. So, how we do that is normalization is a technique used to scale numerical feature common range. We'll have one scale. So, scale you have seen. So scale has, suppose you measure anything with that scale. You have seen a scale with we give rules and all in our houses we have normal scale, right? So scale means it has a normalization. That scale is normalized. That whatever you measure with that, it will be in inches and foots, right? Similarly, normalization here is a technique which is used to normalize because data will have different features. You are not going to have different standards to measure it, right? You can't get mean, mode, and median because of if your data is not normalized. That is the first thing which you have to do to it helps to prevent the large scale for dominating the learning process and improving performance machine learning methods. So you have to give simplicity to the model, machine learning model, huh? It should be normalized, then and only it will give you good output. So minimax scaling is we normalize with minimax scaling scales data to range of 0 and 1, preserving that relative distance between the data points. So we normalize, we do complete chronology, and we do the sequencing, and then and only we give the 0 and 1. So this is how we do minimax. So z-score standardization is we transform data to have a mean of 0 and a standard deviation of 1, making the data less sensitive to outliers. So this is how we have to, because when we do z-score, so we actually make the data less sensitive to outliers, because outliers will create problem for your data. So you need to use these two techniques to normalize the data. Okay, then it will be performing well for your model, machine learning model. Thank you.
Yeah. So next, dimensionality reduction techniques, guys. So this is one of the like a tricky thing. Like I'm able to explain after lots of explanation given by myself in the like in my college days. So I will put it in a simple manner. Okay, the thing is, we gonna convert n-dimensional data to a lower dimensional data. That is high dimensional data to a low dimensional data. That means we gonna create and we gonna use. Guys, I will say with an example. Consider we are having 1 lakh records of consider we are having 15,000 features. Is it necessary for us to consider all the 50,000 features to go for the prediction of the target value? No, right. So there will be some important features. Those things are very interesting and very required for creating a target value. So that is what called as dimensionality reduction. We are just converting from the 15,000 features to just to the important features. Consider just 10 features. Now what happens means we are reducing the complexity of a model, time of the model, and then the performance of the model by just selecting only the important features in such a manner. Guys, make notes in such a manner. It represents the remaining data, and also it is very, very important to find the target value. So that is why we are going for this dimensionality detection techniques. Okay, there are different techniques available, guys. We are having PCA. We will learn one by one very depth. Just understand. Okay, so PCA means principal component analysis, and then we are having linear discriminant analysis, and finally we are having T distributed stochastic neighbor embedding. So these are the different ways where we will be converting the high dimensional data to a low dimensional data. Yes, sir. Over to you.
Yeah. So see, dimensionality we need to reduce. So it's called dimensionality reduction technique, DRT. So dimension, we have to reduce the this what you say, the feature from the, we need to reduce the number of features in dataset while preserving as much as information possible. So you have to reduce it so that this can benefit improving model performance. Because if you have a lot of features which are not relevant for your model, your model will become bulky and it will not perform well. So you need to have only the data which is relevant and which is required for the model. Rest of the features needs to be reduced. Okay, then we use dimensionality reduction techniques. So reducing computational complexity, time and space, which we know, okay, and gaining insights into the data. So that's why we use techniques called PCA. Here you just need to get aware and familiar with the terminology. So we'll apply these in the depth in when we go for project and application. So then in PCA we find principal component that captures the most variance in the data. It captures the most variant, like um variance. So how much is the variance? Okay, so that this is what it captures. Then linear discriminant analysis, LDA, it finds linear combination of features that best separate different classes. So this is what LDA does. Okay, and then we have T distribution, which helps us non-linear technique. It is a non-linear technique for visualizing high dimensional data in a lower dimension. Because see, when you reduce dimensionality, you have to also visualize that how it is behaving. For that, you need to have a technique, and that's why T distribution, T distributed sarcastic neighbor embedding, t-SNE, you short term you can call it t-SNE, which helps us to see the behavior of the data from non-linear to we visualize high dimensional data to lower dimension, because when we are reducing dimensionality, we need to have a technique which will show us that how is data behaving. So that is why these techniques are powerful. Just get familiar with them, so we'll use it and then you'll understand the application part.
Yeah, because like we're gonna see everything in very detail. Yeah. So the next thing is we're gonna see handling outliers and anomalies, guys. So actually we have seen this right before itself. Sir also explained we need to handle the outlier because like they are the very important thing, and they can make damage to a data set. Like guys, believe or not, if you have a data which has like 10 to 20% of outliers, then the data is not good. You just consider to postpone your data and then carry on with some other way of data collection. Okay, so let's see how we can handle these outliers and anomalies. Okay, so first thing, we need to detect. Okay, identify outlier using methods like z-score we have mentioned, right? And then interquartile range or density based method. So we can go for box plot where it will say outliers. So that type of thing we can do. Next, removal. So remove the outlier if you are clearly errors or have a significant impacts on the analysis. So guys, whenever you think the data that you're gonna remove is not that much important to the target value, then you can remove. If you consider it is gonna give that much impact to the target value, try to do some kind of processing onto it, some kind of dummies to it, so that you can just retain that record with some kind of dummy records. Okay. Next, transformation. So transform outlier by applying techniques like capping, and then something called as how to doing mean median, like those things we can do like transform. So finally we are having something called as robust algorithms, guys. You can use algorithm which is less sensitive, like robust regressions or outlier like clustering. The thing is, these are the algorithms that you can use. The thing is, you need to remove the outliers, or you need to handle the outliers in a way so that the model can generalize instead of underfitting or overfitting, or it is not even learning or just memorizing. You need to generalize to your model. So whenever you handle this anomaly or an outlier, I'm pretty sure your data is gonna be 100% ready for your model. Yes sir, over to you.
Yeah, so guys, handling with outliers and anomalies, okay, I'll say outliers are actually sometimes anomalies, but sometimes outliers will be outliers. So I'll say, suppose you have a range of houses. I'll give you a small data set. Suppose your house is with $10,000, then you have $15,000, you have $20,000, and then the other side you have $7,000, $8,000, $15,000, $17,000. So your range is from 20 to $7,000, right? If I will ask you to find a mean, it would be around, I'll say, 12,000 to 15,000 kind of thing, which will you might have a mean somewhere. Okay. Now, there are data points where you have $100,000, $200,000, $300,000. Okay, three data sets, yeah, like data point. So now these would be called as outliers because they are not uh, as per your main data set. Whatever is your journal data set, data points, it is not relevant to that. It is you are around 20 to 10, you have around 8 data points, but three data points are like completely out of the range, not 20, not 50, 100, 200, huh? 300. So that is what is called outlier, which is out of your main baseline. Your main mean, if it is not coming in the main range of your data, where suppose you have 10 data points which under which it is not coming, and it is 9 10 times uh, away from your mean. So that means it is an outlier. So how to detect that, identify outliers using methods called Z score. We use Z score, okay, interquartile range or density based methods. So how to remove them? Removing outliers, if they are clearly errors or have significant impact on analysis, you have to remove them. Suppose this data set I gave you housing prices. So this, in a particular city, if you have this kind of data, you have to remove those data points because it will impact your model. Then transformation. Transformation is we transform outliers by applying technique called Venzorization or capping. We give capping to those data outliers, so we transform them. Or we do robust algorithms. We use algorithms that are less sensitive to our outliers, okay, such as robust regression, outlier resistant clustering methods. So we use them so that the outliers will not impact on your model. That's this is how we can use different techniques to handle outliers and anomalies.
Yeah, that's the thing, sir. Yeah. So finally, we are having the next thing, like preparing data for machine learning models. Whatever we have done, no. So that is what preparing data. Okay. So first thing, we need to split the data, like training and testing and validation. The thing is, you cannot entirely train the model with all the data, because like if we do that, what means you are just learning all the things. Okay. Instead of that, because what happens in that time, the model get overfitted. Instead of that, you need to split the data into training, validation, and testing. So what is my training data? Whenever you train the model is trained by using a training data, and whenever it is training, on the way of training, we will give the validation data to validate your model whether it is just training properly or not. Once everything is done, the trained model is ready, and then it will be just fitting out, just doing some prediction onto the test data. This is what train test split. Next, we are having model selection. So we need to select appropriate model for what is the process. Consider we are having a problem of classifying fruits into apple and orange. Whether we need to use what kind of algorithm? We need to use a classification algorithm. If a problem statement is related to finding a car price or house price, then there is just no point of using classification algorithm, because classification algorithm works best for the classification problem, not best. It will work only for the classification problem. Since this house price prediction and then car price prediction or continuous value prediction, we need to go for some kind of regression problem. So this is what model selection. Next is hyperparametric tuning. Guys, whenever you just build a model, just try to create some hyperparametric tuning, because we are just loading the model from some library called as scalar. We doesn't know what is happening in the background, so I'm just insisting at least try to use this hyperparameter tuning so that you will get the best model for your dataset. Finally, performance evaluation, by like how to evaluate the performance, whether it is working fine or not, how to do that. So if it is a classification problem, we can go for accuracy score. If it is a regression problem, we can go for a R2 score. So this is how you can evaluate the performance. Yes, sir, over to you.
So here comes again the point is like after pre-processing, now your data is completely ready. So once you pass through those filters, I'll call filters, cleaning, pre-processing. You do all pre-processing on the data and then it is ready according to the standards and the definitions of what AIML, data science, and machine learning says. Okay, what are the standards? So once that is done, your data is prepared for the training. Okay, and evaluating the machine learning model. This involves splitting data into training, validation. You have to train now more the data, validating and testing sets to selecting appropriate machine learning models based on the task and data characteristics. It depends on your problem statement, whether it is a classifying problem or it is a categorical whatever. So it depends on that. So what kind of problem statement you have and what kind of data you have according to your problem statement. Then data splitting, we divide data into training, validating, and testing into different sets and assessing the model's performance and preventing overfitting. Here you can prevent with data splitting as an overfitting problem. Model selection, you need to choose appropriate model, machine learning model based on the task and data characteristics. So it would be according to your problem statement, right? Your data characteristics and data. Such classification and regression or clustering. So you have to see which kind of algorithm you use. So based on these three categories, and then hyper tuning is optimizing model parameter which achieves performance on the validated set. So once your data is trained and validation, then you have to do hyper tuning on that data once model is selected, and then you go for hyper tuning. So there is a sequence: data splitting, model selection, then hyper tuning, and once hyper tuning is done, then you go for performance evaluation. So that means you will evaluate the performance of your model. Is it 60%? Is it 70? Is it 80? Is it 90? So 90 and above is called a good model performance, because so if you are getting 90 and above, that's a good model and the performance is good. But there are other considerations which we need to consider. Evaluating model performance on testing set, we use appropriate metrics such as accuracy, precision, recall, app score. Okay, F1 score. So we use different parameters to evaluate the performance of the model. And once that is done, so here we can see how it is performing, and then if we find problem in performance, we have to go again ground zero. We need to check whether my data is properly cleaned, whether pre-processing is done properly, data splitting is done properly, model selection is done properly, hypertuning is done properly. Then again you iterate, reiterate, and see performance evaluation of your model. You have to go back to ground zero and then come back and see your performance. Then you do a lot of iterations, and then you will understand that which model is better for um, uh, your project. Hypertuning, what kind of optimization, validation, what kind of techniques you can use, and then you will get yourself, you will get to know that what kind of uh, how the data is behaving, how the performance is behaving, and you have to go and fine tune everything again and again till you get the best performance. Thank you, guys.
Yeah, that's the thing. So I think that's it. So guys, yeah, we have seen a complete session for data pre-processing. So last session and this session, we are able to just convey whatever the things that we need for data pre-processing now to be successful data scientists, like model creation, like those things. So everything falls under data science, right? So guys, as we are mentioning, data collection is very important. In some perspective, this data pre-processing step is also very important. Okay. Hope you guys have enjoyed this session, and we will meet in the next session. Thank you guys. If you guys have any doubt, just uh, ping us in the comments. We are here to help you. And yeah, hope you guys have enjoyed. We will meet in the next session, guys. Thank you.
Thank you, guys. Subscribe to our channels and also write the feedback or what have you learned, how you're going to apply, and go and watch all the previous sessions 5 to 10 times so that you understand each and every element, absorb the information, digest the information, and apply the information and build something great and solve bigger problems of the world and become a leader and change your life and change others' life, and really go deep into meta level learning and deeply understand these concepts, and so that these concepts are very powerful. We'll be using them in the projects and assignments and in the future. So remember them, do a lot of revision, and then come back to this session, and then we'll meet in the next session. Also, write in the comment section if you have any feedback to improve our sessions so that we will be always improving. Thank you so much. See you in the next session. Thanks.